Hello students, this is Sir Murtaza from Al Murtaza School and welcome you to another lecture of physics. So let's start. So here we are studying chapter number 2, which is kinematics. So we are going to continue that chapter. So first we will look onto the agenda or the topics which we are going to discuss in this lecture video. So our agenda. Our agenda for this lecture is differentiate between distance and displacement, speed and velocity. Previously, we have learned about what is distance, what is displacement, and what is speed and what is velocity. So in this lecture video, we are going to discuss their differences. Okay, so this is our first SLO which we are going to cover in this video. Second, define scalars and vectors. Okay, so for the first time we will be talking about scalars and vectors. Okay, so and the last SLO is differentiate between scalar and vector quantities using examples. So these are the three SLOs which we are going to discuss in this lecture video. So we will start from our first SLO. So the first SLO is differentiate between the following. So as we are talking about the differences, so definitely there should be a table and we will be talking about their differences. So here is a table. In the first column you have distance and the second column you have displacement. So it is very easy to make differences between any two quantities. First, you have to tell its definition. Previously, we have learned about its definition. So the definition of distance is length of a path between 2 points is called the distance between those points. Okay, and the definition of displacement is the shortest distance between 2 points. So this will be our first difference between distance and displacement. Okay, the second difference could be it is a scalar quantity and it is a vector quantity. Okay, as I've said, we will be talking about scalar and vector quantities. So very shortly, we will be talking about scalar and vector quantity. So this is the difference that you have to remember between distance and displacement. Okay, now move forward. Okay, now we will talk about difference between speed and velocity. So again, we have a table, and in this table, first column is the speed and the second column is the velocity, and we are going to discuss about their differences. So the first point will be its definition. What is the definition of speed? The distance covered by an object in unit time. Okay, and whereas the velocity is the rate of displacement of a body. Okay, the second differences could be it is a scalar quantity, it is a vector quantity. What is scalar and vector? We will be talking about in a very short while. Okay, so this is its second difference. And the third difference could be its formula. Mathematically, the formula for speed is V is equal to S upon T. Okay, where S is the distance, T is the time. Okay, whereas mathematically, the formula for velocity is it is again represented by V, but its formula is D upon T, where D represents displacement. Okay, so here we have covered our first SLO, which is very easy, that what are the differences between distance and displacement and what is the difference between speed and velocity. Okay, so now let's move forward. Okay, now we are going to talk about scalars and vectors. Okay, it is very important term, and if you continue your study to a high level, so these are the terms which you used to use a lot of times. Okay, so you should have a very good understanding about what actually are scalar quantities and what are vector quantities. So first we will talk about scalars. Okay, so the definition of scalar is a scalar quantity is described completely by its magnitude only. Okay, so whatever a scalar quantity is, in order to describe it, we just need its magnitude. Okay, what is a magnitude? We have learned in physical quantities that, for example, if I'm talking about length, so I would say like 5 meters or 25 centimeters. Okay, so here 5 meters, the number 5, and 25 centimeter, the number 25 is its magnitude. Okay, so in order to describe a scalar quantity, we just need to describe its magnitude. Okay, and a specific unit. Okay, that is very compulsory. Second, for example, length, mass, time, volume, etc. These are all the scalar quantities. In order to describe length or mass, time or volume, we just need its magnitude. For example, if I talk about time, we just say, for example, 5 hours. Okay. If I talk about mass, for example, we talk about, for example, 25 kg. So it is understandable. So if I'm talking about mass 25 kg, it means that its mass is 25 kg. It is completely described. If I'm talking about time, you say 5 hours. Okay, so it is also completely described that you are talking about 5 hours. Okay, so for scalar quantity, just you need a magnitude. Now, the magnitude of a quantity means its numerical value with an appropriate unit, such as 25 kg, okay, 1.8 meters, and 50 seconds. Okay, as I've told you earlier, what does a magnitude means? It is a numerical value with an appropriate unit. For example, if I talk about 2.5 kg, so we are talking about mass. 1.8 meters, we're talking about length. 50 seconds, we're talking about time. Everything is defined by its unit. Seconds, it means that I'm talking about time. Meters, it means that I'm talking about unit. I'm talking about length. And kg, it means that I'm talking about mass. Okay, so this is scalars. Very simple. A scalar, a quantity which is described completely by its magnitude. Now, what are vector quantities? Let's look onto its definition. So for vector quantities, a vector quantity is described uh, completely by its magnitude and direction. Okay, so here there is one additional thing, which is the direction. In order to describe a vector quantity, it is very important that you should describe its magnitude as well as its direction. Okay, how? We will look to some examples in order to understand it. So this is vector quantity, a quantity that is described completely by its magnitude and its direction. Okay, then for example, if I talk about force, displacement, torque, all these quantities are vector quantities. Okay, then it would be meaningless to describe vectors without telling its direction. It is represented by an arrow at its head or bold letters like, for example, if I talk about force, it is represented by like this or like this. Okay, so what does this mean? It means that whenever we are talking about vectors, it would be meaningless to describe vectors without telling its direction. It is very important whenever you describe a vector quantity, you should tell its direction too. Okay, and another difference is whenever we talk about vector quantities, it is represented separately. How it is represented? Either it is represented by an arrow at its head, okay, like this one, or by bold letters, okay. Now, so in order that we could easily differentiate between scalar and vector quantities, we represent it in different manner. Now, for example, I'm taking an example of force, and then we will understand why direction is very important in order to describe a vector quantity. For example, when we talk about force, in order to open a door, we should specify either to push or pull. Okay, here I'm taking an example of force, and the situation is we have to open a door. And you know very well, in order to open a door, either you have to push it. Push means that you have to apply force in forward direction, or you have to pull it. Pull means that you have to apply force in the backward direction. So this push or the pull, or you could say the force applied in forward direction or the force applied in backward direction, this is actually the direction that you have to specify whenever you talk about vector quantities. Okay, so let's look on to an image that would maybe understand you a bit more better. Okay, for example, this is a door. Okay, this door is closed. In order to open it, we have to apply force in it. Okay, and force is a vector quantity. So here you have seen that this door is opening in the forward direction. It means that in order to open this door, you have to apply force in the forward direction. Okay, or you could say this door can be opened in the backward direction. So it means that you have to apply force in the backward direction. So here I believe that you have a good understanding about why it is very necessary to define direction whenever we talk about vector quantities. The example is very simple. For example, a door, in order to open it, you have to either push or pull it. So the push or pull is actually the direction of the force which you are applying. For pushing, you are applying force in the forward direction, and for pulling, you are applying force in the backward direction. Okay, let's look at another example. For example, you are standing on a stairs, okay, and this time I'm taking the example of displacement. Okay, displacement is another example of vectors. Okay, so whenever we talk about displacement, you have to specify its direction. How? For example, just assume that you are standing on a stairs, on a middle of the stairs. Okay, if I say you, for example, move 3 steps. Okay, so you will ask me that either I have to move in the downward direction, or either I have to move in the upward direction, or either I have to move in the right direction, or either I have to move on the left direction. So it means that whatever I have said, it is incomplete and meaningless. What if I say you just to move 3 steps, but if I say you move 3 steps downwards, so what does this mean? This is completely defined. I am talking about displacement. I have tell you the magnitude, which is 3 steps, and I have told you the direction, which is downward. So this is another example that you can take in order to understand about vector quantities, that is displacement. So whenever we talk about displacement, it is very necessary to describe where to move. Okay, either forward, either backward, either right, or either left. Okay, hopefully you have understood the meaning of vector quantities. Okay, so now moving forward. Okay, now we are looking onto the differences between scalar and vector quantities. It is very simple. Again, we will be having a table, and this is the last SLO for this lecture video. So I'm showing you a table. Okay, this is a table, and again, what you have to do, you have to tell about its differences. So the first differences would be its definition. What is the definition of scalars? A scalar quantity is described completely by its magnitude only, whereas a vector quantity is described completely by its magnitude and direction. Okay, so this is the first difference, and the second difference would be the examples. For scalar quantities, the examples could be length, mass, time, volume, etc. And for vector quantities, the example could be force, displacement, torque, etc. Okay, so I have told you about force and displacement. We haven't talked yet about torque because most of you guys haven't been familiar with the word torque. So in the next chapters, which we are going to study, we will be talking about torque. So torque is again a vector quantity, but just to give an differences, you can write 3 examples, each for scalars and each for vectors. Okay, so this is it for this lecture video. Hopefully you have understood this lecture. In this lecture, we have completed 3 SLOs, and inshallah, we will be meeting very soon in our next lecture video. So till then, Allah Hafiz.